backed by popular demand, our linear program examples started with music. This one, though, how relates more closely to what we're doing. Many years from now, will you still be sending me Valentine? Birthday greetings. All right, here we go. So, will you still love me when I'm 64? Well, let's find out. So this is an old person who's 64 that wants to retire. Question number 4 coming at us. All right, and again, we set up our linear program accordingly. Now, we show these pretty quickly, but if you want to spend some time on them, just hit pause, and you can check them out. All right, so from the question, I just copy and paste this over. All right, so step 1 is I need to define the variables. So I'm going to insert 2 columns here. I highlight them, I right-click, I click Insert, boom, they scoot over. All right, so in this one, I want to be able to say this is the amount invested in each good. Well, that, my friends, is what we call X1, X2, X3, X6, all the way through there. All right, and so what is our goal? Our goal is to maximize the return. Okay, so here we can put total, and we want to maximize a return. So this is equal to some product of all of our x's, comma, our return. All right, so that's going to be our maximized return, and we want to get that the biggest possible. So let's make this light blue is nice, but we're talking money. I want it green. All right, I want lots of green here. All right, so now let's look at what our constraints are. So we have our optimization, and we have our defined our x's, and we have our optimization. So next, all of our variables that we invest, so the summation of x1 through x6, so x1 plus x2, all the way up to x6, has to be less than or equal to $750,000. All right, and I'm going to make just a dollar. Boom, there we go. So I click up here, that makes it a dollar sign. Perfect. Next, each of my individual x's has to be less than or equal to 25%. Okay, so here, let's call this the maximum 25%. And this is going to equal $750,000 times 0.25. Okay, now I'm going to anchor this 750,000, cell C10. So I can just do this and drag it down. Voila. So each of these has to be no greater than 187,500. Next, we want a certain amount of our investment to be in long-term maturity. So I'm going to create another column here of 10 plus years. Okay? And so what I want to do is down here get a total of the amount that I have invested in that. So if I put this as a 1, a 0, 1, 0, and a 1, and then I do a sum product of my x's, comma, this new binary variable of 0, 1. What this will tell us is it's going to do the sum product. So it's going to be x1 times 1, which is x1, plus x2 times 1, which is x2, plus x3 times 0, and that's what we want, because we want this constraint to be x1 plus x2 plus x4 plus x6. All right, so by doing these 1s and 0s, we get that sum product, and we want this to be the requirement that we have is equal to 750,000 times 0.5. So we want it to be, let's make that a little longer, at least $375,000 that we've invested. Okay, so we can do that with just 1s and 0s. But what if there was 400 rows here? That would take a very long time to do. All right, so we're going to change this. I'm going to delete all these 1s and 0s. And I'm going to do what's called an if statement. So this is equal to if, parenthesis, okay? Now it tells me what I need to do for this. The other thing I can do is if I click FX here, it's a wizard here that allows me to do this. All right, so there's 3 parts. We'll do it in the wizard, then we'll do it by hand next. The logical test is if something is true, then what should Excel return to us? If this is not true, what should Excel return? All right, so the if statement is what needs to be true? Well, because we want this to be the bonds that have a 10 plus year of maturity, is if G, or rather F3 is greater than or equal to 10. If that is true, then I want it to return me a 1. If it's less than 10, I want it to return me a 0. And that's how we do the if statement. Okay? And we click enter, and that gives us a 1. If I drag this down, I get a 1, 1, 0, 1, 0, 1, which is exactly what I want. All right, so I did that by clicking this, all right, and then clicking on the fx. Now, if I want to do it just by hand, which at times is a lot faster once you know how to do these if commands, is equal to if f3 is greater than or equal to 10, then return a 1, comma, if it's not, return a 0, close parenthesis. And there we get that. We just drag this down. And there we go. It's not bad. Now our last constraint. Okay? So we need a set from rating. So it says in our problem that we don't want no more than 35% in Dynastar, Eagle Vision, OctaPro. Now it'd be nice if we could do this with an if command. It's a little harder. All right? So Acme Vision's a 0, Dynastar's a 1, Eagle Vision's a 1, 0, 1, 0. Now that we have that, this is going to equal some product of the amount we invest, comma, the rating system. And what's the requirement for this? Is equal to 750,000 times 0.35. All right, and here's the total. There we go. Now everything's set up. We just need to go to Solver. Okay, so here is what we want. So let's go to Data, Solver. Our objective is to get our return to be the maximum possible by changing the amount we invest in each bond. And we're going to have some constraints. The first constraint is that our total amount invested has to be less than or equal to $750,000. Next constraint is that each individual that we invest has to be less than or equal to 25%. Our next is that 35 or 50% is in this, so this has to be greater than or equal than 10 plus years maturity, than $375,000 or 50% of 750. And the last one is that the amount we have in these high risk ones has to be less than or equal to 262,500. Click OK. Simplex, we're doing non-negative. I click OK, and this looks pretty cool. All right, so based on this, I'm going to put 112,500 in Acme Chemical, 75,000 in Dynastar, 187,500 in Eagle Vision, 187,500 in Micromodeling. I'm not putting anything into OctaPro, and 187,500 into Sabre Vision. That means that my yearly income is going to be 68,888, and we've satisfied the requirements. And now I feel indeed that with this, we will be loved when we're 64. With $688,000, you bet they will.